Okay, so we're here again from the past activity that we've done, okay, from the past videos, okay, but we will be we will not be focusing more on the data here, but instead we will be focusing more on the confidence level. Okay, so we use here the 1.96. Okay, the 1.96 is equals to the 95% confidence level. Okay, so the 95 confidence level is widely used as a confidence level for every task. Okay, so here, for example, here, a statistician will say, I am so sure, I am 95% confident that the mean of this data here, okay, from the 100 samples is between 215.57 to 250.29. Okay, when you say 95%, okay, there is a 5% chance that uh, there's only 5% chance that the mean will not fall into that uh, interval. Okay, so here we can also see here the like the mountain shape data. Okay, so the 5% here is the smallest chances. Okay, so when we say here that the 45% here is I mean this mountain shape data here is we can describe here the 90% confidence level. Why? Because here we can see here that there is a 5% chance that the mean of the values will not fall into that. Okay, 5% plus 5% here is equals to 10%. You can see here the alpha. This is called alpha. Okay, 0.10. Okay, and on 95% it's 0.05. Okay, and 0.98 it's 0.02. And 99% it's 0.01. Okay, now if we compare, if we want to know the only side of the, let's say for example here the right side of the table, right side of the data, and we wanted to find that, we just have to divide this 10 by 2. Okay, so divided this by 2, we got these answers here. Okay, because this one here, zero point 0.5 plus zero point 0.5 is equals to I mean here 0.10 is equals to 0.05 from the right side, and 0.05 also from the left side. Okay, and these were the values, these were the z values for that. Okay, what we use here in our example the last time is 1.96 because we use the 95% confidence. Okay, so we had we will try to experiment on that. Okay, so let's say here 90% and here 95% and here 98% and here 99%. Okay, so for 95% the confidence level is 215 um, 215 eh, sorry, values and then we transpose. Okay, so these were the values. Okay, just have to change this one to decimals. Okay, so how about 90%? So what is the z value for 90%? 1.645. Okay, we just have to change this one 45. Okay, now the data becomes 218 to 248. Okay, now we change it to 98%. So the z value is 2.326. Okay, 2.326. Okay, so the C value becomes values again, then transpose. Okay, and how about 99%? So we just have to change again this one to 2.576, and we get the answer of 210 to values transpose. Okay, so here we had to check, we will now check the distance from and to. Okay, so the distance here from here is 29. Okay, so you will notice here that when you say 95% confident, the the range from the range from the possible um, the range from possible uh, what they call this outcome, or the possible mean from the sample, because you were just estimating the possible mean or the confidence interval. Okay, so what you notice here is when you say 90%, the the confidence interval is more narrower. No, it's narrower. Okay, 95%, the distance from to is 35. Okay, and for 98%, the distance is 42.03, and 99% 46.54. Okay, it has a logic, because when you say 99%, you are so sure out of this 46, there is really a 99%. There's only 1% chance that you will not land on the possible population mean. Okay, and this will be the estimated deviation. This is the standard deviation. Okay, and this is the range. Okay, so here we just notice that the higher the confidence level, the higher the range. Okay, and I think that's all, and I hope you learned something from me today. Okay.